everyone. So today we're going to continue our discussion on logarithms, okay? And one of the most important concepts I tried to drive home yesterday was that a log is really a representation of an exponent, okay? Like we always had log of something something equals, and then the thing on the other side was the exponent, okay? So if logs are really just exponents, then all of those rules of exponents that we learned before still apply, okay? And if you remember, when we were doing all of the rules of exponents, it was almost like they had their own set of rules. They didn't follow normal math rules. Like when we multiplied things together, we added the exponents. When we divided things with exponents, we ended up subtracting and so on. So all of those rules are going to kind of come about in a different way, in a slightly different way today. But that's kind of the goal today, is to learn how to combine logarithms. What kind of math are you allowed to do with logs? And then that will hopefully help you with the idea of simplifying logs, which is really what we were talking about yesterday, and doing without a calculator. Okay, so we're going to kind of turn all of these statements here into multiple logs. We're going to show how these things can be kind of spread out and expanded. It'll be just as important for you to know how to go back the other way. Okay, so when I give you this expression here, for example, you need to know how to turn that back into this thing. Okay, it's kind of a two-way street, kind of like the exponential form versus the logarithmic form. Sometimes one is better than the other. Okay, all right, so let's get rid of this. There we go. This first one, actually, we talked about yesterday already. So anything, the log base b, or log base anything of 1 is always equal to 0. Log of 1 always equals 0 because anything to the power of 0 is equal to 1. Okay? So this relationship is just being written in a slightly different way. Okay, this next one, this is called the product rule, or the product property, because it's multiplication. I'm putting this word in here, by the way, because I think on your homework there are some questions that refer to the names of the different properties. So I don't really care that you know them, but you might just want them for reference on your homework. So if you take the log, and it doesn't matter what base you're talking about, if you take the log of two things that are being multiplied together, you can separate it and do the log of each one of them individually, but it would become an addition problem. So this would become like log base b of x plus log base b of y. Okay, so you can separate the x and the y, but you don't just do the log of each one and then multiply them. It would be the log of each one and then added together. Okay? Similarly, when you have division, division becomes subtraction, because if you think back to your exponent rules, when we divided, we ended up subtracting the exponents. And remember, each log represents an exponent. So log base b of x minus log base b of y. And again, it's going to be just as important, probably even more important, for you to go the other way, for me to hand you something that looks like this and know that you can put the x and the y together by multiplying them. Okay? And then this kind of goes along with some of the stuff we talked about yesterday, but if you're doing a log of something being raised to a power, you can actually take that power and swing it down in front as a multiplier. So this can become p times log base b of x. And that's going to be a really important thing when we get into solving with logarithms. Okay? So please take a second. If you need to pause right now and write any of these down, please do. Oh, I mentioned this is the product rule, so this is the quotient rule. And I'm actually not sure what they call this one. Maybe the power. I'm just going to write power with a question mark. Obviously, you can tell that I don't really care about the names of these things so much, but I just want you to know what they're talking about when they refer to these. Okay. So let's talk about how this would be helpful if I had to simplify something like this without a calculator. So here I have two logs being added together. And we know that adding two logs together is the same as multiplying the things that you're taking the log of. So I could really rewrite this. I could combine them and make this log base 6 of 2 times 3. So when I combine them into one log, addition becomes multiplication. Okay? So that really just says log base 6 of 6. And then if you think back to what we did yesterday, we're asking ourselves, 6 to what power makes 6? Well, that would just be 1. Okay? So you probably can't find log base 6 of 2 without a calculator, because you'd be asking yourself 6 to what power is 2. And you also can't find 6 to what power makes 3. But if you add those two answers together, it would always come out to equal 1, because log base 6 of 6 is equal to 1. Okay? So here where we have subtraction, I can combine the 200 and the 8 using division. So this would become log base 5 of 200 divided by 8. Okay, and I can put them back to being division because it was subtraction originally. 200 divided by 8, I believe, is 25. Yep. So this would be log base 5 of 25. And then the answer to that would just be 2, because 5 to the power of 2 is 25. Okay, so that's how these rules are going to come into play here. All right, look at this next one. So with something ugly like this, the very first thing I would do is look for numbers out in front of the logs, like this 1/2 right here, and put those back upstairs as exponents. So this is really 400 to the 1/2 power. Okay? And then I want to work on combining the 85 and the 17 and the 400 to the 1/2. If I combine all of those, I can write this as a single log. So I'm going to say log of, okay, 85 and 17 would combine with division because that's subtraction. So 85 divided by 17 times, and I did times, sorry, I jumped ahead there a little bit, but because this is addition, I know that I'm doing multiplication here. And then times 400 to the 1/2 power. Okay, so let's simplify inside there a little bit. 85 divided by 17. You may not know this off the top of your head, but I hope guess and check wouldn't take you very long. That's 5. 5 times 17 makes 85. And then 400 to the 1/2 power, that's really asking me for the square root of 400, okay? And 20 times 20 would give you 400. So 400 to the 1/2 is 20, okay? Well, 5 times 20 is really 100, so this really just becomes log of 100 after combining all of that stuff. And then there's no base written, so it's really a power of 10. So we're saying 10 to what power makes 100? Final answer there would be 2. Okay. Okay, I know that sounds very confusing, but if you can get these rules, especially, I think these two are probably your most important, and this, I guess these three, okay, that adding two separate logs together is the same as doing the log of the two things being multiplied together, okay? Taking two logs and subtracting them is the same as taking one log of both of them being divided. And then taking this exponent of p and putting it out front allows me to multiply p times that logarithm. Okay, let's try a few more. So a minute ago, just before we get to those examples, these examples in example 1 all had us going back the other way. It all had us taking this and like condensing it, putting it back together. Now we're going to go the other direction, okay? So it says expand by writing each expression as multiple logarithms. So I'm going to separate this into all of its pieces. I have 3, I have x squared, and I have y cubed. And each one of those is going to get its own log. So I'm going to say log 3 and log x squared and log y cubed. Okay? And then I want to think about how are those things connected in the original problem, and turn those into either pluses or minuses. So like the 3 and the x squared, that was multiplication. So I'm going to add these together. And then there was division here with the y cubed, so I'm going to subtract. Okay. And then the only other thing that I might do, and it didn't technically say I had to here, but usually we do when we take this step, is I'm going to take these exponents and put them down in front here. So I would rewrite this whole thing as log base 3, or log of 3, I'm sorry, plus 2 log x minus 3 log y. And that's what my final answer would look like. Okay, for what that asked me, that's all I needed to do. Okay, so on that next one, just remember here that power of 3 really belongs on both terms. That's really like x to the third over 5 to the third. And if you want to make that 5 to the third into a 125, that would be okay. Or you can do what we're about to do. So I've got two separate pieces here. Each one gets its own log. So I'm going to say log of x cubed, log of 5 cubed. Because this was division, I'm going to subtract, and then I would just slide my exponents down in front. So 3 log x minus 3 log 5. Okay, and that's where I would leave it. And again, sometimes it's more of an advantage to have it written like this, and sometimes it's more of an advantage to have it kind of all condensed like that. So that's why you just have to get good at writing them both ways, and that's kind of what we're practicing here. Okay, let's do some solving. So with these ones, you kind of just have to dive in and start moving things around until you get it to a point where you can solve, okay? There's not like a general strategy for these. But like for this one here, I would start by condensing this side. Okay, start by putting all those pieces back together. Probably by putting the 3 up on the 5 first. So this is now 5 to the power of 3 up here. And then because this is addition, I know that I can multiply these two things together. So if I rewrote that all, that would be log of 5 to the third times 2 equals log p. Okay. If I actually do the math inside there, that's going to be 125 times 2. So that's going to become log 250 equals log p. And then from here, because I have a log of something equals log of something, like if log of 250 is equal to log of blank, then doesn't it make sense that this just has to be 250 over here, right? Couldn't I just say from here that p must be 250? I hope that that appeals to your common sense, okay? However, what I want you to be careful of is sometimes people will look at that and they will say, oh yeah, you can cancel out the logs, okay? You're not technically canceling out the logs, but if you're taking a log of one number and having it equal to the log of another number, okay, then you know that those two numbers have to be equal to each other, okay? They have to be the same. The reason that gets tricky is because then if you go up here, sometimes people want to just start crossing out logs right away. You can't really do this step where you put the two things equal to each other until you get to the point where you have a log equal to a log and no other junk, okay? If you still have other numbers or other like operations inside there, you can't start dropping logs out of the equation. This only works when you get to the point where you have log of something equals log of something else. Okay, so let's try that next one, kind of similar. This is subtraction, so I'm going to put these two things together using division. And so I'm going to say log base 2 of p divided by 5 equals log base 2 of 12. Okay, and once again, we're not really canceling out the logs, but because I have log of something equals log of something else, I know my two somethings must be equal to each other. So I can say p over 5 must equal 12.
multiply by 5 on both sides, and I get P equals 60.
Okay, and then last one, log base 3 of P equals 4. Now, if this was another log base 3 over here, then I could just say, well, P equals whatever log base 3 of is over here. But this one doesn't have a log on the other side. So this is probably a situation where I need to get this back in exponential form to be able to solve it. Okay, so I'm going to do this, and I'm going to say, okay, this really says 3 to the power of 4 equals P. And then I know what 3 to the 4th is. It's 81. So 81 equals P. Okay. Sometimes you'll have problems like that last one where you have to do some consolidating first. So sometimes you'll have some problems that look like this, and you have to do some of this kind of thing where you put the numbers back together first, and then you get to a point where you can spin it around and rewrite it as an exponent. Okay, so just be on the lookout for that. But that's really the big new thing today, is how to combine and separate these exponents. All right, so you should have maybe some practice questions to answer right now, and then you also have a homework assignment. Homework assignment today is out of the textbook from section 9-8, and then we will be reviewing and practicing in class tomorrow with a quiz either late tomorrow or early Thursday morning. Okay? Please let me know if you have any questions.